Okay, so thank you very much for the introduction. So I don't need that anymore. And thank you for provoking me to do that. So first, as you mentioned, I want to talk a little bit about history of performance engineering. Then my subjective observation about the current state performance engineering. And then even more subjective ideas what we will have in the future. Again, it is my personal observation and personal thoughts. No science behind it, except first part, which based on some real sources. So let's see. So actually, we had a few computing paradigms which change with time. So it starts somewhere with mainframes, then move to distributed systems, and we get to web and cloud. There is some idea that some kind of more distributed, like IoT, edge, and computing, and so on, ahead of us. But it is interesting that actually performance engineering catch up significantly later. So first you get technology, people start to use it, and performance engineering appears in that new technology usually when it gets close to maturation. So maybe something like 10 years after that new computing paradigm appears. So, and the oldest I could get to performance engineering is 1966, probably the time when we get actually multi-user access to computers. IBM released system management facilities, which basically kind of instrumentation and data collection subsystem. And actually it's still in use for mainframes, and we can trace a lot of notions which we use heavily today by that date, like observability, IT operation, analytics, and even maybe big data. Actually, many statistical and big data application was born to process this SMF data. In 1968, Robert Miller wrote his response time in man-computer conversational transactions paper, which actually started all discussion about human-computer interactions. And there are ideas and many statements made there appears to be valid. Of course, technology change a lot, but it looks like we have very interesting psychology underground on the top of performance. In 74, resource management facility was released, and then Omega Mon claimed to be first real-time monitor. In 75, computer measurement group was created, and which still alive. I am involved in, and right now we get collecting submission for next annual conference, which would be in January. Looks like virtually, but feel free to submit your proposals, any topic related to performance and anything around it would be great. In 77, Best One was released, as capacity and performance management tool, including some modeling and forecasting. Basically, the idea that Jeff Buzen and his co-founders put there still used widely across the industry. So in 70s, we get distributed systems which had less control and less instrumentation. Not say that there is no instrumentation at all. So it was more need for performance design and testing. So in 1990, Dr. Connie Smith published book Performance Engineering of Software Systems, and it wasn't something completely new. It had 15 pages of bibliography. And it is interesting that in 1990, it looks like we have exactly the same problem as we had now. So that is quotation from the book. It says hardware is fast and inexpensive, for example, as reason not to take care about performance. So we have 30 years passed, and I even cannot imagine how many thousands times it's become faster, but we still there. We still have a lot of performance problems. So in 1991, Load Runner was released by Mercury Interactive. I wasn't able to find anything before that as for load testing, so we can assume that it is when load testing was born, or at least close to that, because actually you didn't need much of load testing with mainframe, with many batch load and very good instrumentation and scheduling. So you just run and see what is going on. But as soon as we get to distributed system, we needed some way to ensure performance. And load testing become the main way to do that. Application performance management term was coined by ProgramMart, which acquired by CompuWare in 1999, and it appears that CompuWare still have copyright for APM. Although it was some kind of mainframe tools, and as usually APM understood was probably introduced by Introscope by Wiley Technology in 1998. And user monitoring, maybe it was that product end-to-end watch by Candle, introduced in 98, which did application response time monitor. In 90s, we get web. Most of performance engineering was still applicable. Soon we get few books published, including this couple of books in 98, which already applied performance knowledge to specific web problems. In 2007, Steve Souders published High Performance Websites, so actually introduced web performance optimization. After that, you already needed to look more closely what means performance engineers. Is it still load testing, or it is somebody who work with a web client? And about soon it was web performance optimization community was created. There was Velocity Conference, which were very popular for a while, web performance meetups. Although somehow O'Reilly practically closed Velocity conferences, even with all their popularity. And we got cloud computing, while the term was coined by Compaq in even in 1996. Probably we can trace it to Elastic Compute Cloud by Amazon in 2006. And the main performance part, auto-scaling, appears in 2008 as third-party tools, and only in 2009 Amazon launched their own auto-scaling feature. So let's move to what we have now. We definitely have a lot of changes. What actually changed? First, we got web, which brought back centralization, somewhat what we have on mainframe. So when your system running under your supervision, but we got open and unlimited workloads. Basically, for open system, everybody could connect to use your system, so you can have potentially unlimited number of users. And we have cloud, which brought further centralization and kind of chargeback. The term was used on mainframe when you could clearly attribute money to your consumed resources. In distributed world, it was a little bit more sophisticated. When you bought server, you already paid for it. And now you have exactly money that you pay for usage of specific resources. And another big thing is dynamic configuration, so like auto-scaling. So you don't know what is your system configuration. It is changing on the fly. And we have agile iterative development, when you basically get all this continuous integration, delivery, deployment, which completely change the way we develop software. And now we got a lot of this mobile web performance optimization, rich internet clients, a lot of things move back to the client. So for optimizing client part became important again. Actually, making a step back to mitigate performance risk, we have a lot of different methods. So first, it is single user performance engineering, like just profiling. We have software performance engineering, as described in that Connie Mead book, where we try to model our architecture, find the good performance patterns. We have instrumentation, APM monitoring, observability, so getting into production system, what is going inside, capacity planning, and actually continuous deployment is a way to mitigate performance risk, ability to deploy and remove changes quickly. And of course, we have load testing. And actually, load testing still remains only proactive experimental way to mitigate performance risk. So we have a lot of things that we can do before release to verify our application performance and do any performance experiments. Like if we want to performance optimization, we can apply exactly the same load and see if the change make a difference. In production, it is usually more questionable. You make change and who knows, is it your change or something change in the workload? So let's think, and the dynamic between these methods of performance risk mitigation changing with time. With mainframe, we had a very good instrumentation and scheduling. So basically, you need just analyze performance and plan your capacity to provide whatever you needed. So titles that you since then were performance analysts and capacity planners, which still you can still see, but not often. When we got to distributed system, well, no instrumentation, no scheduling. So basically, the two main methods was load testing and system monitoring, what happens on the system. So most performance titles were performance tester or performance engineer or architect, which usually was, say, higher level performance tester with who could do additional performance analysis and do a few more extra steps. Basically, again, you distributed your software. For example, if you were a vendor, you needed to send CD-ROM to all your customers, and if you have problems there, you need to do all steps again. It is very expensive and take a lot of time. So load testing was very important to make sure that you don't get this problem into production. And then we get web cloud. Again, we get centralization. We could easily monitor your system. And you can do continuous quick deployment and back the change off if something happened. So actually, cost of this error get a little lower. Usually we see now titles like performance engineer, but it's not very established, and I will get into that a little bit deeper further. Some time ago, I was asked to specify 5 trends of performance engineering, which were originally published in State of Performance Engineering report. So I a little bit twisted it comparing with what people usually specify. So here is my 5. First, it is, of course, adjusting to agile and continuous integration, continuous deployment. Actually, it was supposed to be a trivial case for performance testing because you have working system at every iteration, at least supposed to have. But problem is that if you want to do that do performance testing on every iteration and start very early, you need to apply a much more effort, and where you find all your time and engineers to do that. So basically, only way you could go test it on each iteration, it would be automation and perhaps getting other people involved into performance. Was easier to say than to do, but that's what we should do, no way around for iterative development. And then we have integrating performance engineering into DevOps. Usually people point shift left and shift right as trends. I see it as part of the same trend. So before, historically, traditionally, we had performance engineering between development and operations. So we have development, got system ready, do whatever needed to be done from performance point of view, and then get into operation. And now we have a DevOps process. So it is the process getting from development to operation. So we should not be a point between, but get into that process, integrate with the process. So if we getting more integrated with development, we get shift left. When we get more integrated with operations, we get shift right. But here we get some other performance players. So if we historically had here performance tester, engineer, architect, now, for example, we get more and more developers involved in performance, doing some maybe unit performance testing, or we have new role of software development engineer in test as ET, automator actually. On operation side, we see system reliability engineers and new trend of FinOps. So here we get very interesting question. Would role of performance engineer get expanded into development and operation, or vice versa, our responsibility would be moved to other actors like as that and SREs, and we get somewhere to maybe do a few tests in between helping them. And but one comment here. So actually, talking about that, I am talking about high tech, looking mostly in trends in more advanced companies. So in the IT industry in general, probably they cannot be seen so clearly. So maybe there would be maybe 10 or even more 15 years more traditional approach to performance engineering. But that is what I see looking into high-tech companies. So it might be not everywhere yet, but we're moving in that direction. Then context-driven performance engineering, that borrowed term from functional testing. Idea is that, as I mentioned, there are many ways to mitigate performance risks. And now it is not straightforward what you should do. So depending on your specific context, you need to figure out what you do at what stage in what combination. So it probably won't be one or two, probably several ways to mitigate risks, which you apply in different combinations. So including performance testing. So your strategy should include all of them and see kind of big picture how you address performance risks. Then I see trend of integrating everything. I see tools get more integrated and more tools trying to cover all parts of performance. I don't see how that tool would be named. I listed a few names I saw. Different vendors prefer one or another name or maybe something else. So it's up to the future to figure out what actually would be a standard way to do that and standard name for that thing. But trend can be clearly seen. Many tools that started in one specific performance area now expanding in other areas or die. Processes, we can see integration is continuous integration and DevOps, as I mentioned. So we don't have any separate projects. They get intermingled with other projects. And roles. Looks like silo performance roles get extinct. Like at some point we could find people who just develop performance scripts or only run performance tests. You still can find that, but it looks like it is not the way we are going. An interesting trend is chaos engineering, which is a renaissance of reliability testing. Actually, I believe that it is directly related to performance testing, but it was practically ignored for a long time. But now when complexity of system explode, it became very important and started in production with that new name, chaos engineering. Now moving back to testing. And basically, it is reliability testing tools. And interesting that none of basically load testing vendors hide these features in their tools, maybe except network simulation. And looks like it getting new name become more popular, resilience engineering. So I think it will get to that name eventually as a separate sub-discipline. Then I want to mention three not trend but observations. First, that companies with very large scale, non-critical business set fashions and performance, like Google, Facebook, actively promote their processes like system reliability engineering. Pretty good book from Google, and they popularize everywhere. And the main idea is that they could tolerate temporary inconsistencies and infrequent user issues. So maybe you can use kind of canary A/B testing and focuses on handling failures, not preventing them. You practically never hear from this company anything about performance testing or performance modeling. They use it a little bit, and I'm not sure for their business that it's perfect, but my impression that most other companies are not in that category, and they cannot and shouldn't copy that blindly. Second, in 2014, I wrote Good Times for Load Testing, which was kind of a lot of vendors offering free version up to 50, 100 users, a lot of open source tools, a kind of popularity, but probably some at the end. Since I guess a large part of vendors died or disappeared, and what I unfortunately see kind of downward spiral. So we get less interest in load testing, less interest in load testing tools, so less investment going to that, costs money and efforts. So load testing is less efficient and not keep up with what is needed. And I am happy to say that Neotys is probably one exception for that, which make a lot of efforts to promote load testing tools and improve technology, and I'm very happy to see that. And not much to see else, unfortunately. And interesting dilemma I see in testing tools. There is two great ideas which are somewhat controversial. Basically moving tools in different direction. One is everything as code, so basically kind of use performance as code, and another is scriptless AI based, so like easy to make scripts. And actually it is two different directions, and I still looking forward to see to someday how they could combine these two trends, because both has some reasoning behind it. So I'm getting a little behind, so quickly get to future. So what ahead for performance engineering? We have two trends. One, working against performance testing, like replacement by other methods, because it is due to its centralization, moving responsibilities to different other groups of performance professionals, and getting more and more self-managed systems which do auto-scaling and other ways to mitigate performance issues, which is good things, but again, decreased need for performance testing. On another side, there is trends that increase importance of performance testing, like the scale and sophistication skyrocket. For large-scale system, cost of resources become really important. If you optimize usage, you could get millions and millions. Cost of failures increases. And we still have this decentralization trends ahead of us. We didn't get that, but maybe we get there. So it becomes more important to work with these decentralized devices. So actually what we need to do. So it looks like we have few trends that we definitely need to get involved to, like continuous performance engineering, performance testing, no other way with iterative development. Performance as code, looks like also we're getting there. Kind of holistic view of performance, all these different methods, not just centralized on testing. We need to see the whole picture for performance. And if possible, become a center of performance expertise. I'm not sure, maybe what else, maybe something else. So I'm looking forward to get any feedback on that. Alternative scenario may be that we get kind of performance testing get eventually extinct, moving, say, some responsibility to full automation, developers on the left, and system reliability engineers on the right, and professionals migrate one way or another. I don't like that scenario, because in my opinion, automated testing is regression testing, and it will leave big holes in performance engineering strategy, by my opinion. So to summarize quickly, we had these problems with us last 50+ years, so it doesn't look like they go away as these systems becoming more and more complicated. There are many ways to mitigate performance risk. You need to define your strategy based on your context. And of course, performance testing must adjust to industry trends. Some trends are clear, like continuous testing of automation, performance as code. But we are rather in the beginning. Nothing is set in stone yet. So it would be interesting time for performance engineering, I believe. And we always get a new paradigm on the horizon. So thank you very much. And do you have any question, comments?
So thanks, Alexander, for that presentation. So I have, I think I agree with you. The practice is obviously changing. I think, I mean, my belief and my dream would be that performance engineer is supposed to be the enablers for performance. So putting the right strategy at the beginning, enabling SDev or developers to take over on of testing their own piece of code, including on the pipeline, and being part of the integration, and also helping to put the right methodology to monitor. So my dream would be that we are having more and more I would say tasks and influence within the organization. But again, that's only a dream. I think that requires a lot of maturity from the organization, a lot of process to be changed. But I think that traditional performance or central of excellence that we have seen in 12 or 15 years ago is clearly a break to allow performance testing to be enabled everywhere. I think we have to definitely change the way we are providing performance testing to the organizations. But that's again my opinion. But thanks again for.
It is exactly my vision too, but unfortunately, I don't see it always moving that direction. I see two directions. One is I hope that one where hope we will move, and another kind of full automation approach when there are attempts to say simplify and formalize it.
Yeah, and I think the real resilience or chaos engineering. I remember 12 or 15, 13 years ago, we did a lot of failover testing when we did we generate the load and then we were shutting down some nodes or I don't know, breaking a cluster. So we didn't have that automation, but we would do it manually just to figure out, okay, is the I don't know if the failover is going to do the job, or is we gonna discover problems? And it's funny because now everything has been named as chaos engineering, but it was something that performance testers were doing. And I agree with you. I think chaos engineering is I mean, a lot of people are doing it in production, so that makes great sense. But I think when it comes to testing, I think it should be a performance engineering that should take that activity for sure. And just to remind that tonight we have Patrick King from Gremlin that will do a sort of a explanation on how to start in chaos engineering. So if you want to learn more about it, just stay tuned. He will explain us everything. Arinder, welcome back. So I think you took some hours of sleep. What's the time now?
It's 8 o'clock, 8 a.m. Yeah.
Or earlier, coffee time. Coffee time in Australia.
Yes, coffee time. Coffee time. I have the similar view of things that I'm noticing. This is just my observations. As a performance tester or engineer, you need to now start looking towards other things. That whole thing of doing performance testing is not, either we have given it different names like chaos engineering or SRE. Performance testers have to change the way they do things. They have to start looking at that area, or even what you mentioned, right, Henrik, about holistic view, where you basically are the enabler. But that's where I'm seeing the trend moving towards performance testers, or taking over chaos engineering or SRE roles. But as a fundamental, if you're a performance tester, that breed I'm starting to see slowly disappear. That's a harsh word, but I'm starting to see it's not that common anymore. It's businesses are not seeing a value of a performance tester. You can't scale performance testers when you've got 10 different teams or squads running. So you basically start to enable other teams. That's where I'm starting to see things going. Then again, who knows what future lies, but those are the trends I'm seeing.
Yeah, and I think Alexandra made the point. I mean, performance. I think that was part of the state of performance engineering is performance testing, or performance, I would say, is too important for the organization to be led by engineers. I think it's or performance testers. I think it's an overall culture for the organizations. It should be a collaboration between business and IT experts, whatever. that will drive the performance culture for the organization. And you cannot leave that to automation or regression teams, because if you're not being trained or if you're not being frustrated, because I think performance engineers like to be frustrated. If you're not being frustrated in performance world, then I don't get it how you can deliver efficient performance. But that's again an opinion.
And one concern here is that SRE, it is not a new name for performance engineer. SRE, it is a new name for a system administrator. So actually, as system administrator was supposed to look for performance too, so SRE included performance, but it is not on the top of their list. So yes, they need to address it. It includes, so it get they distributed, and you don't have anybody responsible for performance, and that I am afraid not a good thing. That is why we need some kind of performance engineer, architect who specialize on performance.
Yeah, I think also Mercury and then later on HP, but they did a pretty strong, good job, because there was the gold years where there was only one tool, one standard, so everyone took that tool, and then people say, okay, performance. This is what Arinder explained this morning. So they say, okay, performance testing is definitely equal performance testing tools, and that was something that were left in the mind since a couple of years, and now it's starting slowly to remove that idea where performance is much more larger than just load testing. Load testing is a small portion of the performance task, but and I don't know if all these gold years, I would say, of load testing tools has been beneficial for our practice, but now I think we are trying to adapt or to bring value for our organization.
Yeah, that is another concern. That looks like Mercury is then heavily influence industry in general. And now, with all great work you do, it looks like you still mostly address performance community. So it looks like industry somewhat forgot about performance and performance testing tools. There is no enough, say, efforts to go beyond to general industry.
Yeah. All right. Arinder, Alejandro, you're connected. I see that you're connected, but I think you were fixing your mic. Or Arinder, do you have a question for?
Not a question, more another observation. Means it's most of the companies that I deal with are not at the Google or Spotify level. They don't have a massive infrastructure. So for them putting their application into cloud, let's say if you're dealing with 10 TPS or 20 TPS application, for them, if you just put it in the cloud, most of the time it works. You might have to do performance testing in some cases, but do we need performance testing? Because if we just running 10 TPS, 20 TPS, it works. It scales for their requirement. But there's this whole perception also from business based on what load, what the infrastructure and load is. Do you even need performance testing? But if you're looking at 1000 TPS, yes, you will have to start performance testing, tuning your application to fit the workload model that you're thinking will happen in production. A lot of the time, you put the application, it works. That's just an observation I've seen. And then you've got businesses asking the question, why do we need performance testers? Why do we need to do performance testing?
Yeah, and also I think the cloud provider is doing they did a pretty good job and saying that you don't need performance anymore because we have auto scaling and elastic computing. So what do you spend money in testing when we can manage that for you? So I think there's many people saying that, and also at the beginning you mentioned about it, saying that I remember there was a couple of even 10 years ago saying, why should I do performance testing or why should I do measure anything in my systems? I'm just going to buy some extra hardware and the problem will be solved. So that's a mentality that's obviously yeah. I don't align with that, but
And that is very beneficial for cloud providers. If you use more hardware and auto scale it to thousands nodes, that is money that coming to them.
yeah, it's true. So I think it's not only about this is why performance is not only about response times. There's a lot of other stuff that we should control and secure.
Yeah, and good things that now resources that you consume are money. So if you optimize your application to work 2 times faster and use 2 times less resources, you save half of money for that, for computing.
Yeah. All right. Thanks a lot, Alexander. Thanks for this this session. That was pretty. I really appreciate it. It was really good, and the history piece. I think it's pretty interesting to see that this practice has been there since many years. It's always when I discovered that 1960 we had already that task. So that was interesting, especially when you presented last time in Vegas. So thanks, Alexander. So that ends the financial resource zone. So thanks to all the speakers of the zone. So Todd, thank you for your session. Christian Espinoza, thank you. Oscar as well, and thank you, Alexander, for your presentation. Thanks.